So I was going to drill the holes in these parts, but then I realized we still have to machine the base to a 219 thickness from its 250 thickness it is now. So let's go ahead and do that while we still have the fly cutter in the spindle. Just throw a couple. This is an easy one. Just throw a couple parallels in. Set the parts on it. Tap them down, and let's take a cleanup cut on this side, and we'll flip them over and take them to thickness. Alright, now take another 10 thousandths off here and set our dial to 0, and we'll measure them and see how much farther we have to go and finish them up. Alright, side's cleaned up, dial's set to 0. Let's throw my micrometer on and see where we're at. It looks like about 239. Shooting for 219. What did I say? 239. 234. No, I was right the first time. 239. It's getting late. Alright, so 239 minus 219. I'm not going to rely on my brain for this. It's getting too late. Got 29 thousandths to go. Got 20 thousandths to go. Take that one pass. It's a good finish cut. Should be good. Let's double check it. 218. Okay, that is a 3-place decimal, so that's plus or minus 5 thousandths. So we're within 1 or 2. Good to go. Let's go ahead and deburr these, and we'll drill some holes. Alright, now I think to drill the holes we're going to have to change our setup a bit here. Also, we're going to have to take a look at our drawings, because now we're at the point where these parts start to differ from each other. The base, for instance, has a 7/32 hole through it with a countersink. The base, the top plate has a 7/32 hole with a countersink. The base has a 5/32 hole through it with a smaller countersink, and the middle plates have a 7/32 hole through them with no countersink. So we have to kind of not get confused here over which parts we're working on. Now it looks like 2 of them have 9/32 holes through them, so let's start with those. the top plate and the 10 middle plates. So we need all the 1/8 inch pieces have a hole in them, 219 thousandths diameter plus 5 thousandths minus nothing. Okay, that's a tolerance on the high side. That's so the shaft always goes through the hole, so the hole can't be too small for the shaft. The shaft will have a minus tolerance on it, so it can't get too big and the hole can't get too small. So let's see, what's the best way to do this? I think we'll make use of our V-block again here. I'm going to stop, set the stop, put the V-block against it, and I think we can just stack our parts up in this corner here. Not these parts though, because these are the bases. Let's set these aside so we don't get them mixed up. So I think we can fit a whole stack of the 1/8 inch pieces in here. And I think since these are probably a little bit of variation in them, we better stick a piece of paper down here. Take up any irregularities. Alright, that looks good. Let's get this fly cutter out here. We're all done with it. Drill chuck in, ready to drill some holes. Okay, so the first thing we need to do is locate the hole we're going to drill. Like I said, it's a 219 hole. I'm just going to use a 7/32 drill for that. Drills always drill slightly oversized, so I'm just going to run it through there, and it'll be probably 220, 221. It won't be undersized, I can guarantee you that. Alright, I think for using the edge finder and setting up the drill, I think I'm going to go handheld here, so bear with me. For those of you who have not used an edge finder, all it is basically is a pin that's kind of spring loaded, and the pin is a known diameter, and we just turn the edge finder, turn the spindle on, and run the edge finder against an edge like a solid jaw of the vise or the edge of the part, and it'll true up, and then it'll kick off to the side. When it kicks off to the side, that's the point where the edge finder is 1/2 the diameter of this pin away from the edge. So you gotta run the edge finder in till it touches, until it kicks out, and then move in 1/2 the diameter of that pin. That will put the center line of your spindle right on the edge. Let me show you how that's done real quick here. A little bit of a challenge working one-handed, but let's see if I can make it work. Alright, let's see here. We just move in until the edge finder centers up and then kicks off like that. Okay, that's where we stop. Now we know we're 1/2 the diameter of that pin away from the edge. So now you can be using a digital readout. You can zero out that axis, and the pin is 200 thousandths diameter. We can compensate for that by moving over 100 thousandths. So that's that edge. The other edge, probably make you all sick with my shaky camera work here, but hopefully not. Now we'll pick up this edge right there, see it kick out. Go ahead and set up or zero out the x-axis, compensate for it. Alright, so the digital readout's all zeroed in now. If I go to 0, 0, that, and like that. That puts us right on the corner of the part. All right, if you don't have a digital readout, let's do it with the dials. Alright, same thing, we'll just run in and get a different view of it here. You can see it zero out or center up, and then it'll kick off. As soon as it kicks off, you stop, then you set your dials. See if I can do this with one hand. I know the pin's 100 or 200 thousandths of diameter, so I'm going to do my offset right here. Set the dial to 100 thousandths. Okay, now when we move in to 0, alright, pretty close, about 6/10 off, puts us right over the edge of this back jaw, the solid jaw. Alright, let's go ahead and put a drill in. We're drilling a 219 thousandths diameter hole, so we'll put a 7/32 drill in. And we want to be, let's look at the print here, we're going to be a 1/4 inch off of each of those edges, 250 thousandths. So let's go ahead and move the y-axis first, set that 250, and then we'll do the x. Or you could use your dials, either way. It's the thing about machining, there's no right or wrong way, or there's no one way to do things, as long as you end up with the proper part in a safe manner. That's a good method to use. Okay, so let's go ahead and drill a hole through these 10 pieces, 11 pieces. Made sure that the parts are setting up on a parallel, and where the drill breaks out is over the opening in the center of the vise, so I don't have to worry about drilling into my vise. There we go. Takes care of that stack, and I'll do the same thing to the other stack. Let me put this camera back up on the tripod to make it easier to use. So we got one stack drilled. Let's go ahead and drill the other stack. Get these out of here. This time I think we'll use a little WD-40 as a lubricant for the drill, make it a little nicer hole. We did that on the last hole, but I only had 3 hands as it is. with the 7/32 drill. And we're done with these for now. So let's set them aside. And let's go ahead and put the 5/32 hole in the base plate. While we're set up here. Alright, just to double check this on the print here, it is a 5/32 hole, 156, and it is the same tolerance as the 219 hole in the other one, +5 minus nothing, so we'll use a 5/32 drill. And I've got that part in there backwards, or 90 degrees out, so let's correct that. Like I said, it's getting late. Alright, that looks better. Okay, let's go ahead and drill that hole through. That's it for the holes. Now, while we have the drill chuck in, let's go ahead and do the countersinks. Some of these holes have countersinks in them. The base plate is one of them. It has a 200 thousandths diameter 90-degree countersink. Do the countersinks right here on top of the chuck. Nice and easy place to work. Only one side's countersunk. Let's go ahead and deburr the other side. Set our stop. Make a little countersink and set the stop, and then we can check the diameter. It's supposed to be 200 thousandths. It's about 180. Let's go a little deeper. Just raise the table up a bit. Check it again. And it's about 200. Okay. It is a two-place decimal, so it's pretty loose. All it is, when this thing's all stacked up, this is the bottom of the plate. All this countersink is we're going to peen over the shaft where it comes through here. You're going to peen it over and kind of rivet it, and this countersink is just to allow the end of the shaft to fill the hole. So there's nothing critical about it. Let's go ahead and do this other one. Stop's all set. Okay, these parts are done. So the base plate is finished. Let's set that aside. What do we have left here? The middle plates are finished. Well, they're not. They're finished as far as the hole's concerned. So we'll set 20 of those aside. All we have left in the hole department is to put a 350 thousandths countersink, 90 degrees, into the top plate. making 2 assemblies of those, so let me grab 2 parts here. Go ahead and deburr one side of it. And I think probably we're going to have to do this a little different. I think 350 thousandths diameter. I think the countersink's going to go all the way through, so I'm going to have to bridge. Have some place for that to go. I don't want to countersink the top of my vise. So let's just put it between the jaws of the vise like this. Alright, what are we doing here? Again, this is 350 thousandths, 2-place decimal. It's not that critical. Just kind of sneak up on it till we get the diameter right. That's about 330. Come up a little more. That is about 340. All I'm doing is bumping the table up with the crank. Probably can't see that in the video. Alright, that's about 350. Go ahead and do it to both parts. Okay, these countersinks that I'm using, they're really nice countersinks because they don't chatter. They're single flute countersink. All they have is a hole through them to serve as the cutting edge. So they do a real nice job, especially on aluminum, handheld no less, and there's no chatter at all. So these are great countersinks. All right, so that's all the hole part drilling we have to do. Next up is we'll go ahead and mill the corner radii, and that will pretty much finish this part up. Let me get set up. So I'm set up to cut the 1/8 inch radii on the corners of these parts. I have an 1/8 inch corner rounding end mill. I did a video on how to use these things, so I'm not going to go into a lot of detail. Let's get this chuck out of here. Alright, we're just going to set them on a couple of parallels, doing all the parts at once here. I am going to use a piece of paper between the jaw and the parts because clamping on them on edge like this, there's bound to be some of them that are slightly smaller than others, so we'll compensate for that with a piece of paper. Use a lot of paper when you're milling. You put paper underneath the part, between the part and parallels, so you can tell when the part's down tight. That's a good thing to use paper for. Put it between if you have a part that's not held real tight, paper will increase the gripping power of the vise. You can do what I'm doing here. It evens out the pressure on parts that might be slightly different. You know, paper has a lot of uses. I think that's what half of my drawings get used for, torn up and used for spacers and shims. Get a little closer to the edge. I also like to, when I'm milling parts like this, I also like to put a C-clamp on just to keep them from tipping. Just kind of a little insurance policy. Alright, so let's go ahead and mill some radii. Okay, basically just touch top surface and back off a couple thousandths. And drop down and do the same on the back side. Touch it and then just back off a couple so you don't go too deep. Alright, that should take care of this corner. Corner rounding end mills like the climb mill. I don't like the conventional mill. I mean, you can do it, but it's going to leave a rough finish. Well, that's one edge, one corner. Let's go ahead and flip it over and do the other corner. Actually, I should probably hammer these down. That would help. Kind of forgot to do it on the other one. They're still pretty well aligned. These should be even better. That's that corner. One more to do and we'll be finished with these parts. So one of the hazards of shooting live video is having the battery go dead and not noticing it, which happened last night. So I went ahead and finished up those parts, finished cutting that corner radii to a dark camera. Luckily I had another set ready to go here. These are really handy to have, so I made up, actually I made up 6 sets of these things just to have for myself after this video's done. So let's go ahead and finish cutting the last radius on the back corner here. Let's see how we're going to get in there to do that. Probably like this. There we go. Paper again as a spacer to take up for any irregularities in the parts, and a C-clamp to keep them from getting loose when we're milling the corner radii. Just hammer them down against the parallel. And we'll finish these guys up. So that about does it for these parts. Well, not these parts. I gotta put the holes in these yet, but the ones we made yesterday are all done. I'm gonna have all kinds of stack blocks here. So the next video in line, we'll go ahead and make the shaft, the pivot shaft for these things, and we'll get a set of them assembled and see how they look. See you then.